scientific notation is a way of expressing really big numbers or really small numbers, which we deal a lot with in chemistry. Like one of our favorite numbers is Avogadro's number, which is 6.02 times 10 to the 23rd. Now I don't want to write 21 zeros after my 602, so using scientific notation makes it a much more concise way to do that. So your scientific notation is going to consist of two parts. It's going to be a number between 1 and 10, not 10, but up to 10. And it's going to have a power of 10. So if n here is your number, times 10 to the x is what the general form for scientific notation looks like. So to go from standard regular numbers to scientific notation, we're going to move our decimal point so that there's one non-zero digit to the left of the decimal point. So we need one number in front of the decimal point. Then you're going to count the number of places that your decimal has moved. This is going to be your exponent. Then you need to decide if your exponent is positive or negative. So if you have a very small number, okay, the number was less than 1, then your exponent is going to be negative. If you had a very large number, the original number is greater than 1, then your exponent will be positive. So for example, if we have this number here, at this point our decimal is here at the very end of the number. And a lot of times when you see numbers written in science, you will not see the commas like we are used to putting. The reason for that is other countries use commas the same way we use decimal points. So in an effort to create a worldwide system, we just put a space here and no comma. So at this point, here's our decimal. All right, so we're going to move our decimal point so that it appears after the 2. And we count 1, 2, 3, 4, 5, 6, 7, 8 places. Now this is a very large number, so that means our exponent is going to be positive. So we write our answer as 2.898 times 10 to the 8. And you do need to write all these numbers when you because we need to include all significant figures. So if we have this example, our decimal point is obviously here. We want to move it behind the 5. That will give us one non-zero digit in front of our decimal. So we move it 1, 2, 3, 4 places. And because this is a small number, then our decimal point will be negative. So you would write that as 5.67 times 10 to the minus 4. Now to move...
Did you think I was Jen?
All right, sorry for that interruption. That was Mr. Hutchinson. All right, to change scientific notation to standard form, you're going to move the decimal point to the right for a positive exponent. Remember, positive exponents mean big numbers. And you'll move the decimal point to the left for a negative exponent. And you use zeros to fill in the places. So for example, if we have 5.093 times 10 to the 6, this is a positive exponent, which means we're going to move the decimal point to the right, so it'll be a big number. And then we'll need to add zeros to accommodate where we've left off. So 1, 2, 3, and then we need to add 3 zeros so that we will have moved 6 places. If we have a negative exponent, we're going to move our decimal point to the left, so we will have to, again, add some zeros. So if our decimal point was right here after the 1, 1, 2, 3, 4 places to the left. And if you want to double check yourself, you can put these into scientific notation, and I will check them for you.